Good morning, champs. We have water in a closed tank, part liquid and part vapor. Can we figure out how much is liquid and how much is steam? Yes, using a simple idea called the lever rule. Let's look at the problem. We have a rigid tank with a volume of 20 liters and a total mass of 0.1 kilograms of water. The system is heated until it reaches 120 degrees Celsius. At this point, liquid water and water vapor coexist. Now we start solving. First, we compute the specific volume. Specific volume is volume divided by mass. So we take 0.02 cubic meters and divide by 0.1 kilograms. This gives us a specific volume of 0.2 cubic meters per kilogram. Next step, we go to the steam tables. At 120 degrees Celsius, we read three important values. The saturation pressure is about 1.99 bar. The specific volume of saturated liquid is about 0.00106. And the specific volume of saturated vapor is about 0.89. Now we compare. Our value, 0.2, lies between these two limits. That tells us we are inside the liquid vapor region. So we have a mixture. Now comes the key idea, the lever rule. We want to find how much of the mass is vapor. The formula is now we insert the numbers. 0.2 minus 0.00106 divided by 0.89 minus 0.00106. This gives approximately 0.224. So about 22% of the mass is vapor. Now we compute the masses. The vapor mass is x times the total mass. So 0.224 times 0.1 kilograms gives 0.0224 kilograms. The remaining mass is liquid, so about 0.0776 kilograms. And here is an important insight. Even though only about 22% of the mass is vapor, it occupies most of the volume. That is because vapor has a much larger specific volume than liquid. Let's summarize. We computed the specific volume of the system. We used steam tables to identify the phase region. Then we applied the lever rule to determine the vapor fraction. And from that, we obtained the mass of vapor and liquid. So the key takeaway is this. Inside the liquid vapor region, the position between the two limits tells you how much of each phase you have. That's the lever rule.